The following is a graphic depiction of a violent prehistoric battle. Viewer discretion is advised. They were the elite killers on planet Earth. Apex predators, monsters that ruled every corner of the globe. They ranged from the giant T-Rex, who relied on size and long curved teeth, to the smaller raptors who used speed and cunning. We now know that these dinosaurs were widely different in how they looked, how they lived, and how they hunted. They're the Earth's first fighters, the ultimate predators. New discoveries in forensic science bring to life the prehistoric art of war. This is Jurassic Fight Club. Prehistoric Earth, 350 million years ago. The continents as we know them don't exist. There is one major landmass called Pangaea. On Pangaea, the cities of Hong Kong and New York would have been separated by only 3,000 miles.
At the end of the Jurassic, the supercontinent of Pangaea was disintegrating. The individual components that made up this huge landmass were beginning to rotate first at different rates and then in different directions. This caused huge rifts between these landmasses and ultimately created the continents we see today. As they continued to break apart, the environmental changes in some cases were catastrophic.
156 million years ago, during the Jurassic, oceans were far more widespread than any other time on Earth. Through the forces of plate tectonics, the land masses shifted and sea levels rose, flooding large portions of North America. Where our major cities are today, Houston, New Orleans, Miami, and even the Heartland, are submerged in waters hundreds of feet deep. The ocean extends all the way into central Utah. It was in this world that the first big killer would arise. The terror of the Jurassic, Allosaurus.
The name Allosaurus means other reptile. It lived in western North America during the late Jurassic period from 156 to about 145 million years ago. Its remains have been found in Colorado, Utah, Wyoming, and Montana, and at its time, there was nothing as bad as Allosaurus.
Allosaurus was really the first of the truly big meat-eating dinosaurs that was found and was known from fairly complete remains. It was the Tyrannosaurus rex before there was a Tyrannosaurus rex, both in terms of geological time and its discovery.
Powerfully muscled, the Allosaurus was able to hunt huge herbivores, such as the 2-ton Stegosaurus.
Allosaurus, in its time, was the top predator. It was a combination of a lot of really useful traits for a predator. It had powerful jaws with pretty sharp teeth. It had large claws on its hand, which were very useful for gripping and tearing. So it combined a lot of useful traits as a hunter.
Allosaurus has got relatively long arms for a big predatory dinosaur. Most predators have these little arms and they're not very effective weapons, but Allosaurus is different. He's got 3 enormous claws on each hand, and listen, you don't have big claws to play the piano, you have big claws to rip somebody's head off.
I think another way to look at Allosaurus is if you would take a wolf and make it into a 2-ton animal, put it on 2 legs, put Edward Scissorhands-like arms on it with giant claws, and then maybe put the skull of an alligator on top of that chimera animal. Allosaurus was a fast, strong, ferocious beast.
It stood 13 feet tall, measured nearly 40 feet in length, and weighed up to 4 tons. Those numbers make Allosaurus one of the biggest meat eaters of its time.
The reason why Allosaurus and other dinosaurs were able to grow so big is because the oxygen levels were much higher back then than they are today. And so dinosaurs were able to extract oxygen without much effort, and therefore they could carry a heavier load and live more active lives even though they were huge.
During the late Jurassic period, oxygen levels had been estimated to be as high as 35%. Compared with today's 21% oxygen levels, it made life much easier for the larger dinosaurs.
So how on earth could anyone know what the oxygen level was a million years ago? Well, the answer is amber, fossilized tree sap. We find all kinds of prehistoric insects, plants, and even small reptiles trapped within amber. We also find gas bubbles, and so scientists are able to drill into these pieces of amber and extract the oxygen bubbles within them. This is how we know what the percentage of oxygen used to be.
Higher oxygen levels also allowed the plant eaters to grow enormous, and Allosaurus was perfectly suited for taking on big game.
When you look at the foot and the leg of Allosaurus, it's certainly quite powerful. I mean, Allosaurus was a large theropod of its time, one of the top predators. So not only was it built to carry the weight of the animal, but also was no doubt used to hold down carcasses and things like that.
You have to remember, what was Allosaurus eating? And they were eating some of the biggest animals the Earth has ever seen. Allosaurus was feeding on sauropods, animals that are multi-times the size of our largest mammals today, the elephant. And they were bringing these animals down.
Allosaurus is an example of how all life adapts and changes to the environment. First, you have trees that begin to grow to outrageous sizes, and it's also when we see the long-necked dinosaurs emerging to take advantage of these tall trees. Camarasaurus was the most common and successful dinosaur of that time. Then Allosaurus had to grow huge because his prey was becoming so huge. So in a sense, you could say Allosaurus grew big because trees grew big.
This was a good, all-purpose, generalized animal, and I think that's one of the reasons for its success. It was very widely distributed and fairly abundant, and that probably was because it was generalized enough that it could adapt to a wide variety of different environments, take a wide variety of prey, and as a result, flourished.
Its ability to adapt allowed Allosaurus to become one of the most successful predators of the late Jurassic. Its long, stiff tail gave it excellent balance, allowing it to hunt in the open and in dense forests. The landscape of modern Utah scarcely resembles what it looked like 156 million years ago, when Allosaurus ruled supreme. There were fewer mountains, and seasons as we now know them did not exist. And there was water everywhere. Rivers, ponds, and lakes covered much of the state.
The entire floodplain was probably scattered with these rivers, with ponds and lakes and large meadows. There were a lot of fairly large trees. Trees that were probably 100, 200 feet tall. Lots of ferns, lots of cycads, lots of ginkgos, lots of interesting plants, but of course none of them flowering plants or grasses or fruits or anything like that.
Only those dinosaur bones buried in sediment, often by rain or flood, survived to be fossilized. This sediment provides crucial information.
Different types of physical environments produce different sorts of sediment. And we can go out in the modern world and look at a stream valley versus a desert versus the open plains, and each of them has a different pattern of sediments being produced, and therefore different types of sedimentary rocks and structures. Also, the plants vary from environment to environment, and so we can look at whether we're seeing ferns, or herbs, or trees, or other remains of fossil plants to reconstruct the living environment.
By extracting oxygen and carbon isotopes from the sediment and analyzing their chemical makeup, geochemists can find out things such as temperature, humidity, and even weather conditions from the prehistoric world.
And by adding all these bits and pieces together, we can create a much bigger picture of past climates and past atmospheres, and therefore past environments.
Throughout the Jurassic period, the Earth's climate was hot and humid. This created a supersized world. Today, trees in Utah reach an average of 40 feet. During the Jurassic era, they were 140 feet, fueled by the abundance of water and oxygen. This lush environment provided a banquet of food for the plant-eating dinosaurs, who in turn became a banquet themselves for new species of meat eaters. The top meat eater of its time was Allosaurus. More advanced in both brain and brawn than its competition, it literally ate them into extinction.
One of the main competitors of Allosaurus was Ceratosaurus. Now, Ceratosaurus had appeared on Earth long before the first Allosaurus showed up, but towards the end of the Jurassic, we find fewer and fewer skeletons of Ceratosaurus, but more and more skeletons of Allosaurus. This suggests that Allosaurus was out-competing Ceratosaurus and ultimately displaced it as the top predator of its time.
Allosaurus had little trouble dispatching its rivals. But nature was slowly tightening a noose around its neck. By the end of the Jurassic, the planet was beginning to cool.
As the continents continued to break apart, it changed the ocean currents. This in turn had various effects on the weather. Now, a change in the weather may not sound like a big deal, but every single life form owes its existence to the environment. And when that environment changes, it sets into motion a series of things that can start to fall like dominoes. And the bigger you are, the harder you fall.
Gigantic dinosaurs like Allosaurus required large amounts of food and water to survive. Even a slight drop in temperature would, over time, reduce its food supply enough to spell extinction. For 11 million years, Allosaurus ruled Western North America as the undisputed biggest killer. But its inability to adapt to the changing environments of the late Jurassic would open the door for a smaller, faster model. One that was terrifying and sported a weapon unlike anything before it. With temperatures dropping, the first ice caps formed, the oceans cooled, and seasonal changes in weather patterns began. The entire face of the planet changed, and the dinosaurs were dramatically affected.
At the end of the Jurassic period, the Earth had begun to cool. Dinosaurs like Allosaurus, Ceratosaurus, Camarasaurus, and Stegosaurus were unable to adapt to these changing environments, and it ultimately wiped them from the fossil record. A change in the climate usually means a change in plant life. If the herbivores can't eat these new plants, then they perish. And then, in turn, the predators have nothing to prey on, and they die as well.
Over the next 90 million years, a new era called the Cretaceous period dawned. Broader leaf plants that could tolerate seasonal weather changes covered the landscape. Only the most adaptable, intelligent herbivores were able to adjust, which meant the meat eaters had to adapt as well. For the first time, brains over brawn became the key to success, which ushered in the era of the raptor. The Utah raptor was an early example. It was still fairly large, but the trend towards sleeker and smarter was clear. In some ways, the Utah raptor provides a missing link in the chain of raptor evolution.
When Utahraptor was found, it was pretty significant because up until that point, the largest of the raptor dinosaurs found was Deinonychus, which was about the size of a timber wolf. And here comes one with similar sort of anatomy, but bigger than a bear, or at least the size of a big grizzly or a big polar bear, a truly monster-sized raptor dinosaur.
Pound for pound, this is the most terrifying dinosaur that ever walked the earth. It's relatively fast, intelligent, and loaded with weapons, and it brings all of these things together within a body that's built like an athlete. During the mid-Cretaceous period, this thing, without a doubt, was the most dangerous and nastiest animal on planet Earth.
The name Utahraptor means thief of Utah. This large bird-like dinosaur was a deadly, efficient thief of life.
Utahraptor was a major predator for its time. It was one of the top predators in its environment. It would have been something like a big wolf or a big cat for today. Actually, a tiger would be a very good model for Utahraptor.
He's not just big, he's huge. The discovery of this dinosaur is stunning because now we had a raptor that was twice as big as any ever found before. And the fact that it was so big tells us that this particular raptor was really more of a heavyweight fighter than a finesse hunter like the smaller raptors.
If I were to design the perfect killing machine, I'd build a raptor. If I was going to build the perfect raptor, I'd build a Utahraptor because it's just the right size. It's the right size for killing almost anything.
Utahraptor stood 6 feet tall and weighed over 1,500 pounds, which made it a top killer of the Middle Cretaceous period.
The raptor family is made up of a lot of different individual dinosaurs. Deinonychus and Dromaeosaurus are examples of raptors. These animals were built a lot like birds. Well, when we look at the skeletal design of a raptor, what we see is very similar to that of a modern turkey or a rodent. So like modern birds, their bones are hollow. This means they're very lightly built, but they're still really strong. It allows them to run at high rates of speed, but still engage in full-on fights.
But a recent discovery proves that raptors were even more closely related to birds than once suspected.
Birds have really specialized lungs. What they do is they have a series of air sacs throughout the body. Some of them even enter the vertebrae that fill up with air and push air out, and fill up with air and push air out, like a series of bellows.
But for the raptors, the air goes into their lungs, but then it's distributed into vertebrae and bones throughout the entire body. This is why they're so fast and deadly as hunters. Fresh air only travels one way into its body and fueled them with plenty of oxygen.
Like all members of this family, Utahraptor had massive claws on its hands and feet, and it used them like a world-class chef to slice and dice its meal.
The killing claw on the foot of Utahraptor, like all dromaeosaurs, is definitely its primary weapon. It had stout, powerful legs, and the claw tended to be that the bone core of the claw is around 8 inches, so with the keratin sheath, it could have been up to 12 inches or longer. So that's Utahraptor's primary weapon. But like all meat eaters, it also had a battery of formidable teeth, and then huge hand claws that could have also inflicted damage.
The raptors were amazingly dexterous at using both feet and hand claws.
Well, picture this animal that would have weighed close to 1,000 pounds, being able to kick this thing with slashing strokes, 3 and 4, 5 foot long strokes, plunge it in through skin an inch thick, slash down 10 inches deep, and cut 3 feet long, and do that every couple seconds.
Along with its deadly claws, Utahraptor relied on its teeth as an effective means of killing its prey. And to ensure it always had a fresh set, Utahraptor had a special adaptation in its jaws.
When we look at the jaw of something like Utahraptor, really many of the predatory dinosaurs, we see that all the teeth aren't really at the same level, but rather they seem to be, some are really poking out a lot and some are just a little bit. What that is actually reflecting are the way that the teeth are replaced. So they actually grow at different rates and at different times. These reptiles, like Utahraptor, are actually replacing teeth throughout their life. So they've got teeth that are actually at different stages of their growth and different stage of eruption where they are in the jaw at different parts of their life. This is actually a very wonderful strategy because these animals are actually breaking teeth. Their lifestyle of actually biting into other animals is pretty tough on their teeth. And as a result, they are breaking teeth and wearing them down, yet there's always one in replacement. So they're always equipped with a series of these dagger-like teeth.
Along with its sharp claws and replaceable teeth, the Utah raptor was a master strategist.
When we do CAT scan of raptor skulls, we can see that these raptors, like Utah raptor, had really fairly expanded brains. So we see expansion of the higher centers of the brain, the parts of the brain that are associated with maybe even some cognitive capabilities, ability to solve problems.
These guys had a pretty doggone advanced brain, very much like living birds of today. Very smart animals. Don't mess with a raptor, you're gonna lose.
Being smarter than your prey is an excellent way to remain a top predator, but the ability to adapt to environmental changes is what makes any dinosaur successful. And in Utah raptor's time, the environment was going through some very dramatic changes indeed.
Over the next several million years, the Earth continued to cool, and seasons became more extreme. Plants became increasingly diverse to adapt to the changing seasons. Herbivores ranged far and wide to find suitable food, and the Utah raptor adapted its hunting strategies to take advantage.
When you're a predator and your environment changes, you need to adjust your hunting methods accordingly. If you're used to hunting in dense forests and then those forests are replaced by smaller bushes and open country, then you better be prepared to tweak your hunting methods. And Utah raptor was an expert at doing just that.
Utah raptors staked out the migration path of the herbivores, often referred to as the Cretaceous Highway, and waited in hiding for their unsuspecting prey.
Utah raptor may have been more of an ambush predator. In other words, we might say that if Velociraptor were a cheetah running things down, that Utah raptor may have been the equivalent of a lion in the sense that it may have lay in wait for prey and with a quick, short burst of speed taken something, but it wasn't an animal that probably ran things down over a long distance.
Utah raptor was fast, but the cooling climate favored even faster, smaller models. Future raptors would evolve to stand only 4 feet tall. They would rely more on agility and cunning than brute strength, and they would render the Utah raptor obsolete. But halfway around the globe, another killer was perfectly suited to his environment. It was the apex predator of his territory, and is often called the T-Rex of the East. $70 million years ago, the Earth was cooling. Ice caps formed at the poles, and winters were becoming harsher, with temperatures dropping below 40 degrees. Those temperatures would seem relatively warm by today's standards, but for life in the Cretaceous period, it's much colder than anything the dinosaurs were used to.
The Cretaceous period was much cooler than that of the Jurassic that preceded it. Well, this was all due to the breakup of Pangaea and then ultimately Gondwana and Laurasia. The sea levels rose and fell, the jet streams in the atmosphere were altered, and currents in the ocean were affected. The life that was hit the hardest was that lived on the smaller land masses. Larger areas have more buffer than smaller ones when it comes to climate change.
In North America, the larger Allosaurus had given way to the smaller raptors. Off the west coast of Africa, on the island of Madagascar, another downsized advancement for the Allosaurus became its biggest killer. Referred to as the T-Rex of the East, its name was Majungatholus.
The name Majungatholus is derived from the words Majunga, which is a district of Madagascar where they found the dinosaur, and Tholus, which means dome in Latin. This hideous-looking dinosaur first appeared 70 million years ago and lived up until the end of the Cretaceous, when all dinosaurs went extinct about 65 million years ago. Its remains are only found on the island of Madagascar, but it has relatives in South America. That proves that at one time, Africa, Madagascar, India, and South America were all connected in the supercontinent of Pangaea.
Majungatholus belonged to a family of dinosaurs called the Abelisaurids. This family of dinosaurs shared several characteristics.
The Abelisaurids are a group of meat-eating dinosaurs, descendants of creatures similar to Ceratosaurus from the Jurassic period. The Abelisaurs tended to have relatively short faces, they tended to have very thick snouts, and they had very short, bizarre arms, where the hands were very, very small, and the forearms were shrunken up, so they're basically just wrists. The Abelisaurs started off as sort of a secondary predator, a middling-sized predator in the southern continents. But in the late Cretaceous, when the Allosaurs had finally all died out, the Abelisaurs took over. And if you were in South America, or Africa, or India, or Madagascar, your greatest fear would be an Abelisaur.
Some of the early descriptions said it's a face that only a mother could love. It's a very ugly, rugose-headed dinosaur. Its nasals are completely covered with lots of little pits and divots in the skull. It's a very ugly dinosaur, but very cool-looking dinosaur to paleontologists.
Along with its unusually hideous face, Majungatholus sported a horn that jutted out from the middle of its forehead. Ironically, this menacing spike may have served an important social function.
When the first really nice skulls of Majungatholus were found, one of the things that was very apparent was that there was this very complicated and rough-looking bump on top of its head. Now, we see that lots of different kinds of dinosaurs, including many kinds of predatory dinosaurs like Ceratosaurus and Allosaurus, and even some specimens of Tyrannosaurus, have various kinds of horn-like structures or bumpy structures on their head.
I think that with the majority of these theropod dinosaurs that have display structures on their head, they're probably related to identification of the animal, so that potential rival males can identify that there's a male who is going after your females, or the ones you're interested in. Or they can also tell the female that you're the right age and you're of interest.
The extreme appearance of the Majungatholus may also have been something of a freak of nature.
Anytime we have a small population of animals isolated in a small area, you can't help but get inbreeding between family members. Over long periods of time and numerous generations, we start to see mutations caused by inbreeding. Now, in the case of Majungatholus, so few skeletons have been found that we really don't know what normal looked like for this particular species, but we can certainly suggest that because it lived on an island and it was separated from other similar dinosaurs, its ugly face could have been the end result of mutation.
The Majungatholus was small compared to many of the dinosaurs of the Jurassic period, but it was still substantial in size. It stood 9 feet tall, was 28 feet long, and weighed 1 ton. On the tiny island of Madagascar, it was the biggest predator by far. Its jaw structure made it a particularly potent killer.
Majungatholus has a very, very interesting skull. It's not only shortened and very high, but the bones of the skull are interlocking. Now, that's important to know because most theropods, most meat-eating dinosaurs have very kinetic skulls where their skulls will actually move while they're feeding, helping to protect their teeth from breaking the bones of their skull. from breaking, and also their jaws would expand when they opened their mouth. But Majungatholus did not have that ability, so it was really a skull that was solid and had very, very little, if any, movement.
Majungatholus' strength would be its very powerful bite. It was a short, powerful skull with a rather powerful neck. If it could clamp down on something and bite on it, it could deliver a really nasty wound from that.
He's got a big, thick bulldog head, and it's perfectly designed for grasping prey and crushing it. His teeth are also designed to take a lot more pressure than many other predatory dinosaurs. They were blade-like, but not so thin that they were breakable. His teeth are its #1 weapon. Its secondary weapon would be the claws on its foot. They use their feet the way modern birds use their feet. Look at an eagle. An eagle can grasp prey with its foot. Well, Majungatholus could do the same thing. He could grasp it to hold it, and then he used those teeth to rip chunks out of it.
For 9 million years, Majungatholus ruled Madagascar. But as temperatures around the world continued to cool, the Majungatholus was not fast or smart enough to survive. Winters became harsher than ever before, and the peak of summer saw droughts of devastating intensity. New species of plant eaters evolved. These herbivores were smarter, more adaptable, and could survive in a variety of temperatures. Once again, meat eaters had to change to keep up. In Canada, where the winters were cold and dark and the summers were desperately arid, a faster, savage cousin of T-Rex was on the rise, and it was smart enough to hunt in packs. "76 million years ago, a relative of Tyrannosaurus rex roamed North America. It was smaller and sleeker, had a narrower skull, and its eyes were placed more to the side, but it was almost as deadly. It was Albertosaurus."
Albertosaurus gets his name from Alberta, Canada, where some of these monsters have been discovered. But it lived throughout western North America, possibly as far north as Alaska and as far south as Texas. They appeared 76 million years ago and died out with the other dinosaurs at the end of the Cretaceous. These were big, but really fast hunters. They were as bad as it got for a while.
Albertosaurus would have been a very fearsome predator. It comes with that basic tyrant dinosaur package. The powerful teeth for smashing through flesh, for breaking up bone, a powerful set of jaws for tearing out big chunks of meat, and behind that, a very fast-moving body. And as far as Tyrannosaurs go, Albertosaurus was probably among the fastest. So if T-Rex is the SUV or the Mack truck version, Albertosaurus is the sports car. The same basic design, but sleeker, more elegant, and almost certainly faster as an adult.
With its massive head, powerful jaws, and elongated teeth, it's easy to mistake this dinosaur for its relative, Tyrannosaurus rex. But Albertosaurus preceded its cousin by almost 10 million years.
Albertosaurus is a more primitive Tyrannosaurus, so that for a scientist, we can actually distinguish them without any trouble whatsoever. But to a person just looking at the animal from the outside, you're not really going to be able to tell them apart, other than by size. I mean, a Tyrannosaurus rex can be up to 40 to 45 feet long. An Albertosaurus is generally, say, about 30 to 35 feet long. Nevertheless, if you had an Albertosaurus chasing you, I'm not sure you would care that it was not Tyrannosaurus rex.
Albertosaurus stood 11 feet tall at the hips, and weighed as much as 3 tons. In North America, he was one of the biggest killers of all time. But it wasn't only big. This dangerous dinosaur was fast, a good tracker, and smart enough to execute basic strategy.
When we look at an animal like Albertosaurus, we can see really a sensory machine, a whole series of brain and ear structures that allowed it to see well, had a very heightened sense of smell, and a really good sense of hearing.
It's a bipedal carnivore. It was very fast. It had, relative to size, also comparing with T-Rex, its arms appeared larger. They're almost the size of T-Rex arms in terms of length, but it's a much smaller individual. So you can kind of get the idea that their arms were perhaps more important to them, or at least looked a little bit larger in comparison.
Albertosaurus's weapons are all up front. It's the head and it's those teeth. Those teeth are the #1 weapon. That's how the animal defends itself. It's how the animal attacks. So in a fight, what it would do is it would face its attacker and rush in head first with those massive teeth and grab his prey and rip a huge chunk out of it. Their teeth are recurved, which means they sort of point backwards, and they were also very blade-like and had serrated edges.
3 tons of terror moving 30 miles per hour would have been an awesome sight. But what made them even more fearsome was that they hunted in packs.
We've collected, in fact, 12 good skeletons in southern Alberta. In addition to that, we have a bone bed that Barnum Brown worked in 1910, where we have parts of 23 skeletons of Albertosaurus. And these are everything from 2-year-olds to 25-year-olds.
There's adults, there's juveniles, there's subadults, or what we call teenagers, all found together at the same time at the same place. And this suggests that they may have operated as family groups. So they may not have merely been very powerful predators, they may have been very powerful pack-hunting predators.
Fossils of varying sizes have been found buried closely together, pointing to the fact that Albertosaurus may have formed true family units. This would have increased the safety of their young and helped the Albertosaurus spread across North America. But even these well-adapted dinosaurs were vulnerable to climate change. In the late Cretaceous period, temperatures inexplicably began to climb.
A pretty dramatic change in the climate was becoming obvious at the end of the Cretaceous. We find fossil evidence of cold-blooded animals and plants that don't really tolerate the cold that well being found in the polar regions. Why the Earth began to warm after the cooling period is still a mystery. One interesting hypothesis involves the larger amounts of water that once covered much of the Earth. Rather than absorb the heat, they may have radiated it back into the atmosphere and caused a greenhouse effect. Whatever the case, these changes were tough to deal with for some dinosaurs, especially those up north.
The colder temperatures and more extreme seasons had caused dinosaurs to downsize. Rising temperatures would reverse the trend, opening the door for one of the most terrifying predators the world has ever seen. As temperatures rose in the late Cretaceous period, lush foliage grew, supporting larger and larger herbivores. These giant plant eaters, such as the Triceratops, also developed horns for protection. This caused the meat eaters to develop new weapons as well. The result was a predator whose name instills fear even today. It is known as the king of the dinosaurs, Tyrannosaurus Rex.
Tyrannosaurus Rex is, without a doubt, the biggest and baddest predator that ever walked North America, and quite possibly the world. They first appeared during the late Cretaceous about 68 million years ago and lived right up to the extinction of the dinosaurs about 3 million years later. Their range included Montana, Wyoming, Colorado, New Mexico, South Dakota, and Canada, and even as far south as Texas.
T-Rex stood out as the largest predator in North America. It weighed up to 7 tons, stood 16 feet tall, and measured 43 feet in length.
There's no animal living today that has had the strength of Tyrannosaurus rex. To try to come up with something that had that kind of power, I don't know, a howitzer, you know, like this animal was so strong that there's nothing that could escape if it decided it wanted to eat it.
And when it ate, it had a mouthful of banana-sized teeth, designed to slice through meat and crush bone.
Its teeth are gigantic. They are thick from side to side. They're not cutting teeth by any means. These are pulverizing teeth. These could pierce through flesh, they could shatter bone, and they're anchored by extremely deep roots.
The tooth of a dinosaur gives us a pretty good indication of its diet. Now, there's other ways to determine what an animal ate, and it has nothing to do with the teeth. It's poop, fossilized dung. They call them coprolites, and yes, even that stuff can become fossilized. By slicing it very thin and looking at it under magnification, we can actually see the remains of what the dinosaur ate. So by looking at the teeth and then looking at the dung, we get a picture of what was happening in between.
Its teeth were huge, but its small arms were barely longer than a man's. Tiny as they were actually functional.
One of the things that people always mention and always think about is, why did it have such puny arms? Well, the arms are kind of small. I mean, they're a little bit bigger than mine, but they were really well muscled. But still, the claws on these hands were huge, and they could actually act like meat hooks and perhaps even stabilizing the prey.
Along with its enormous size, one feature set T-Rex apart from all other meat eaters: true binocular vision.
It had forward-focusing vision. It could focus in on something and know where to hit.
T-Rex almost certainly had a pretty good visual field overlap, meaning it had pretty extensive binocular vision. What we see in the brain is that indeed the brain is structured to, in a sense, process that visual information.
Much of the T-Rex's brain power went to his vision. In terms of intelligence, it probably wasn't quite as smart as a house cat. When the dinosaur faced mass extinction at the end of the Cretaceous period, likely due to an asteroid strike, even this monstrously powerful beast didn't have the tools to adapt and survive. Dinosaur extinction was a dramatic twist in an evolutionary saga that began with the first days of life on Earth. Nature has launched a relentless assault against her inhabitants, throwing up evolutionary roadblocks at every turn. The human race is the first to face these challenges with a highly developed brain, and that is its greatest hope for survival.
Although some of the climate changes that occurred may have taken hundreds, thousands, or even millions of years, that's just a blink of the eye in the evolutionary terms. It takes hundreds, if not thousands, of generations to be able to adapt to a particular climate. People look at the animals in the Arctic and wonder why they just can't adapt if it's getting warmer. Well, it's not just a matter of dealing with the heat. There are other issues, things like metabolism, reproduction, food intake, and even respiration that they have to deal with. When it gets warmer or colder, people have the ability to change the environments we live in, but animals don't have that convenience. There were no thermostats in the age of the dinosaurs.
The ability to use tools helped the human race weather the ice and the great warming that followed. But it is certain that nature has not finished creating challenges to its survival. And humans are the first species on the planet to affect its environment as much as it is affected by it. Whether this will prove to be an advantage remains to be seen. Next week on Jurassic Fight Club. Gastonia was built like a prehistoric tank, its body covered in armor. Huge spikes jutted from its back, and its tail worked like a chainsaw. But it lived with the most terrifying creature on the earth. One of the first raptors, it was 1,500 pounds of pure hell, and the smartest dinosaur of its time.